Teacher Joshua, your mathematics learning guide here at DepEd TV. This is the last chapter of our first quarter journey. We will apply our knowledge and skills we acquired in the last few lessons as we explore different ways on how to solve systems of linear equations. So buckle up and get your self-learning module, pen, papers, and ready yourselves for the challenge ahead as we learn graphing systems of linear equations in two variables. Do you still remember the piggy bank or alcansya we discussed from the previous lesson? We may start earning little by little. Keep in mind that a small progress is still a progress that could lead us to a better future. Looking back at the previous situation that we explored last time, there were 1 peso and 5 peso coins in your alcansya. You know that you have 10 coins with a total amount of 22 pesos. From that information, we wrote the mathematical model to represent your savings. We let X be the number of 1 peso coins and Y be the number of 5 peso coins in your alcansya. And the mathematical model for our savings is given by two equations, x plus y equals 10 and x plus 5y equals 22. We learned that this kind of situation, having two or more linear equations in two variables, is called a system of linear equations, or also referred to as simultaneous equations. Recall that the solution to a system of equations is the set of ordered pairs xy that satisfies all of the equations in the system. There are many ways to solve a system of linear equations. Today, we will explore on how we can identify the solution by graphing the system of linear equations. Do you still remember graphing the linear equations? The process would still be the same for graphing the system of linear equations. It's just that all the linear equations in the system will be in the same rectangular coordinate system. Let's try to solve the acquired system of linear equations by graphing. Given a system with linear equations x plus y equals 10 and x plus 5y equals 22, we first graph the first equation, x plus y equals 10. The easiest way to graph this is by finding the x and y intercepts. For the x-intercept, we let y be equal to 0. The equation x plus y equals 10 becomes x plus 0 equals 10, which simplifies to x equals 10. We now have one ordered pair, 10, 0. To find another point, let's find the y-intercept by letting x equal to 0. From x plus y equals 10, we will have 0 plus y equals 10, or simply y equals 10. Therefore, we have the second ordered pair, 0, 10. Since we now have two ordered pairs, we can now draw the line. Plot the point 10, 0, then 0, 10. Connecting these 2 points, we now have the line representing the set of solutions for the linear equation x plus y equals 10. We may now graph the other linear equation in the system using the same rectangular coordinate system or Cartesian plane. We have x plus 5y equals 22. Again, we may use the intercepts. For the x-intercept, we let y be equal to 0. The equation x plus 5y equals 22 becomes x plus 5 times 0 equals 22, which simplifies to x equals 22. We now have one ordered pair, which is 22, 0. To find another point, let's find the y-intercept by letting x equal to 0. From x plus 5y equals 22, we will have 0 plus 5y equals 22. By the multiplication property of equality, or MPE, we have y equals 22 over 5, or 4.4. Therefore, we have a second-ordered pair, 0, 4.4. We can now plot these points and draw the line on the same rectangular coordinate system. Plot the point 22, 0, then 0, 4.4. Connect these 2 points to form the line. Now we have the line representing the set of solutions for the linear equation x plus 5y equals 22 by connecting these 2 points. Since the system has 2 linear equations, we can see 2 lines in the same rectangular coordinate system. The question is, where is the solution to the system of linear equations in this graph? Take note that the solution to a system is the set of ordered pairs x, y that satisfy all equations in the system. Therefore, the solution to the system of linear equations is the point of intersection of the lines in the graph. In this case, the point of intersection is at 7, 3. And we may say that 7, 3 is the solution to the given system of linear equations. From the method that we used from the previous lesson, we got the same answer by solving the system graphically. We can now conclude that there are 7 1 peso coins and 3 5 peso coins. Since there is a solution, we can say that the given system of linear equations is a consistent system. We also conclude that it is an independent system because there is only one solution. Let's try to solve another system of linear equations graphically. Consider the system containing the linear equations 2x plus y equals 6 and 6x plus 3y equals 12. Graph the first equation. There are different ways to graph a linear equation, but since the given is already in standard form, it would be easier if we look for the intercepts. To get the x-intercept, we let y equal to 0. 2x plus y equals 6 becomes 2x plus 0 equals 6 by substituting y equals 0. This simplifies to 2x equals 6, and by the multiplication property of equality, we have x equals 3. We now have an ordered pair 3, 0. Next is to find another point. We can look for the y-intercept by letting x equal to 0. The equations 2x plus y equals 6 becomes 2 times 0 plus y equals 6, or y equals 6. The second ordered pair that we identified is 0, 6. We can now plot these points on the rectangular coordinate system. The x-intercept 3, 0 is on the x-axis 3 units to the right of the origin, while the y-intercept 0, 6 is on the y-axis 6 units upward from the origin. Finally, connect these 2 points, and we now have the graph for the linear equation 2x plus y equals 6. Next is the other linear equation in the system. 6x plus 3y equals 12. Again, since it is in standard form, it would be easier to find the intercepts. Let y equal 0 to get the x-intercept. By substitution, the equation 6x plus 3y equals 12 becomes 6x plus 3 times 0 equals 12. This gives us 6x equals 12, or simply x equals 2 when dividing both sides by 6. So, the first ordered pair is 2, 0. Next is the y-intercept. The equation 6x plus 3y equals 12 becomes 6 times 0 plus 3y equals 12 by substituting x equals 0. This gives us 3y equals 12, or simply y equals 4 after dividing both sides by 3. We now have the second ordered pair 0, 4. Let's proceed to plotting these points to the same rectangular coordinate system we used a while ago. Since we have an x-intercept 2, 0, plot this on the x-axis, 2 units to the right of the origin, while the y-intercept 0, 4 is on the y-axis, 4 units upward from the origin. Connecting these 2 points shows us the graph of the linear equation 6x plus 3y equals 12. We learned that the solution to the system of linear equations is the point of intersection of the lines in the graph. But observe the graph. Do you see a point of intersection of the lines? There is no point of intersection. We actually have here a pair of parallel lines. What can we conclude from this? We can say that the given system of linear equations doesn't have any solution. So, when a system of linear equations has no solution, we call it an inconsistent system. Let's take a look at another system of linear equations. Consider the system with equations x minus 2y equals 2 and 2x minus 4y equals 4. Identify 2 points by taking the intercepts. What is the x-intercept of the linear equation x minus 2y equals 2? It is 2, 0. How about its y-intercept? Very good. It's 0, negative 1. Plot the points 2, 0 and 0, negative 1. And connecting these 2 points, we now have the line for the linear equation x minus 2y equals 2. Let us proceed on the next line for the equation 2x minus 4y equals 4. What do you think is the x-intercept? It is 2, 0. Then what is the y-intercept? We have here 0, negative 1. Next is to plot the intercepts and connect. We now have the line for the second equation. Observe the lines we graphed. How many lines are there? We actually graphed 2 lines that are coinciding with each other. Since we have coinciding lines, where all points in one line are also the points of the other line, what can we say about the solution of this system? Knowing that a line has infinitely many points, we can say that the system of linear equations has infinitely many solutions. Since we were able to find solutions to the system, we call it a consistent system. More specifically, a dependent system, because there are infinitely many solutions. Now let's have one last example. Consider the system of linear equations y equals negative 3 halves x plus 2 and y equals negative 1 half x minus 2. Observe that we have here equations in the slope-intercept form. So we can plot the y-intercept first, then find another point using the given slope. In y equals negative 3 halves x plus 2, the y-intercept is b equals 2, while the slope is negative 3 halves. So plot the point 0, 2. And from this point, we locate another point 3 units downward, then 2 units to the right. Next, connect these 2 points to form the line. Next is the second equation with y-intercept b equals negative 2 and the slope of negative 1 half. Plot 0, negative 2. And to locate the other point, we move 1 unit downward, then 2 units to the right. Connecting these points, we now have the line for the second linear equations. On what point did the two lines intersect? They intersect at 4, -4. Therefore, we say that the solution in the given system of linear equation is 4, -4. That has been a lot of linear equations that we graphed for today. As you practice, in time, you would feel that graphing systems of linear equations is actually easy to do. From today's lesson, we were able to solve systems of linear equations graphically. We simply graph all the linear equations involved in the system using one rectangular coordinate system or Cartesian plane. Then finally identify the solution, which is their point of intersection. Aside from that, we were also able to explore and observe from the graph the types of linear equations. When the lines of the equation in the system intersect, the point of intersection xy is the solution to the system. It is also called consistent and independent. When lines coincide, it means there are infinitely many solutions in the given system of linear equations. This is a consistent and dependent system. And lastly, when the lines are parallel, it means that there is no point of intersection. Therefore, there are no solutions. This is called an inconsistent system. We learned a lot from applying the skills we acquired from the previous lessons and through a lot of observations. Let's take some exercise. Given the system 5x plus 3y equals -12 and 2x minus 3y equals -9, with graph as shown, what type of system of linear equations do we have here? A. Consistent and independent. B. Consistent and dependent. Or C. Inconsistent. There is a point of intersection. Therefore, we have letter A, consistent and independent. Number 2, what is the solution for this system of linear equations? A, 1, -3. B, -3, 1. Or C, no solution. Since the lines intersect at -3, 1, then the solution to the system is letter B, -3, 1. Consider this system of linear equations. What type of system of linear equations do we have here? A. Consistent and independent. B. Consistent and dependent. Or C. Inconsistent. We can see that the lines are parallel, so there is no point of intersection. Therefore, the given system of linear equations is C, inconsistent. We can also conclude that there is no solution for this system of linear equations. Did you get them all correctly? I know that you can do it. Keep on polishing your skills and you will be a master of mathematics in no time. If you find the topic difficult, you may consult your self-learning module or visit the DepEd official YouTube channel and review our lessons. Next episode, we will learn another way to find the solution to a system of linear equations. Because the more we know, the better we can think and consider which method is more appropriate for different instances. With that, this is Teacher Joshua reminding you to practice, do it with a positive attitude and a smile on your face. Keep on being critical, logical, and responsible grade 8 students. See you again for a math terrific day here at DepEd TV.